Welcome. I am Magellan, a GE research vessel and your host. You may have noticed the young man before you is practically frozen and you are completely invisible. Don't panic. This is normal and absolutely essential for this experiment to work. This is our friend and talented musician, Ruben Wu. Go ahead, step in for a closer look. He won't mind. Ruben has generously allowed us access to his brain, so we can experience firsthand what it looks like inside the mind of a musician. This scan of Ruben's brain, produced on GE Healthcare's MRI machine, will help us navigate through this experience, look around it, and take a peek inside. Before we take off, I'll mention 2 safety points. Be sure to stay on the platform, and you'll find it more comfortable not to move around while we're moving. Okay, let's get going. Initiating miniaturization sequence. I love that part. Stimulating prefrontal cortex, entrance point activated. Wow. I was expecting Ruben's cerebrum, though it appears we've been captured by his mind's eye. Okay, this is exciting. I present to you Ruben's imagination.
Welcome to the complex universe inside Ruben's head, the crown jewel of the human experience and home to nearly 100 billion neurons communicating through trillions of connections. That's more connections than stars in our galaxy. Like music, the brain embodies its own complex rhythms. While each neuron has its own firing pattern, groups of neurons can synchronize to build a stronger and more efficient connection. A process critical to learning and making memories. Your thoughts also create rhythms. By concentrating, your brain produces rapid electrical impulses, known as gamma waves. And when relaxed, it generates slower, alpha waves.
Okay, would it be weird to say this is blowing my mind?
As music involves practically every part of the brain, we invite you to explore any region of Ruben's brain you desire.
Amazing. Now that we've been delighted by the brain's creative abilities, let's pull back the curtain and see what it actually looks like. Catch a ride through this neuron and check out my favorite part of the brain, the amygdala. Enter nucleus. Stimulating. And here we go. It's beautiful, isn't it? We're gazing upon one of the greatest mysteries in the known universe. Right here in the amygdala, within these millions of neurons, we know Ruben's emotional learning is being processed, along with his fears, social interactions, and memories. We're working hard to help unravel this great mystery, developing new brain imaging technologies and collaborating with the world's best brain health researchers. Understanding the complexities of this 3-pound supercomputer is extremely challenging. So much so, it's estimated our knowledge of the brain is roughly 50 years behind our knowledge of nearly every other organ in the body. If we're able to understand the brain as well as we understand other organs, we can help more than 450 million people living with neurological diseases worldwide. Let's head back to the loft and revisit the MRI scan of Ruben's head. here we go, my favorite part. I'm just saying, I think Ruben has a giant head. Okay, initiating expansion. Expansion complete. Activate MRI data. Let's start by retracing our journey from Ruben's frontal lobe to his amygdala. Now, imagine a future when physicians, scientists, and researchers are armed with even more real-time, high-resolution brain activity and a spectrum of related diagnostics. And, like our trip through Ruben's mind, the ability to access and analyze a single neuron for study or repair. Well, it's time to let Ruben have his motor skills back. It was an amazing brain that we experienced together, and I hope you'll join me again. There are trillions of connections happening inside the universe in our head. We're working to visualize them all.